In this video, I'm going to focus on among the gravitational, universal gravitational law. We're going to focus on the inverse square law. So let me share the note. So again, the gravitational, the universal law of gravitation is Fg. G is the universal gravitational constant that applies to any object. M1, M2 is the mass of the two objects divided by the distance square, which is the distance between the two objects that has M1 and M2 mass. So from here, you can see the gravitational force is inversely related to the square of the distance. And this is called, inverse square law. Right? That it's related to 1 over d squared. You see that a gravitational, what it means is that gravitational force weakens by 1/4 if you have a double the distance in between. If you increase the distance by 2, it weakens by 1/4. So as farther away, one over d squared. So what it means is that, for example, twice, so if you have a twice the distance, force decreases, sorry. Forces, it's okay. Twice the distance, force is 1/4 weaker. And imagine if what it also means is that as the distance becomes infinity, so if you put the two objects farther and farther away, bigger and bigger distance away, like this, it's gonna get the intensity of the force gonna approach to 0, but actually it's never reached 0. So the force field, it goes forever, discontinuously. It goes forever. Although it's very, very tiny, you're supposed to have a force even though you go to infinity. So let me share this slide here. I can do this slideshow from. So inverse square law relates the intensity of effect of inverse square distance from the cause, right? Equation, it means the intensity of a force, or in this case, it's a force. So intensity is by 1 over distance square, 1 over d squared. So as you have an increasing distance, there's going to be the intensity of the force decreases in 1 over distance square. At great distances, force approaches to zero, but never reaches zero. Let's see. So here's a good one. So you have a can of a paint here, right? You have a can of paint. And then at the distance d away, at this point, imagine you have a sheet. And this can of a spray, you know, put the, if it's red, or this case is green, I guess, it becomes green, saturation from the paint. Let's move this, but if you were to move twice of the distance away from the can, now the can of a spray spreads out in a way that you need 4 sheets to cover up the same amount of to cover up the same amount of ink that came out from the can. And therefore, it becomes the saturation of the each same unit area becomes the 1/4 less saturation. So it's not going to be a strong color. It becomes 1/4 less for the twice of the distance. If you move it 3 times farther from the can to cover the same amount of ink that comes out from the can, now you need how many? How many area do we need? And therefore, how many layer thickness? How much is the saturation for the each intensity of the color for each unit paper? Let's move it to a 4 times farther from the can. So now it requires how many sheets to cover the whole ink that comes out from the can, that you move 4 units of the distance. How much is this? And also how thick, how strong intensity, saturation is going to you see in each paper. So that's going to be here. It's going to be 9 times 9 area units and 1/9. Now it's going to be 16 and then a 1/16. Right? So this is called inverse square law. As you go farther away, the intensity decreases by 1/d square. Also, here's another good one. The y-axis shows the gravitational force. So the gravitational force of this object at the surface of the Earth is this much, okay? On the surface of the Earth, the gravitational force is this much. It could be 10 Newton, it could be 100 Newton. Let's say 100 Newton on the surface of the Earth. Then let's say this is the radius of the Earth, from the center of the Earth onto the surface, right? So we call that as a 1D. 1D is the 1 radius of Earth, which was 6.36 times 10 to the 6 meter. So let's move up in, you shoot up on the sky, move another radius away. So that's going to be 2D, right? So you move from the surface of the Earth up 6.36 times 10 to the 6 meter above the ground. How much gravitational force have you decreased to? So if you had a 100 Newton, what do you think it became? It becomes 1/4 of 100 Newton. So what do you think? 25 Newton. Right? If you move 3 times of the Earth radius, becomes this much. 4 times becomes this much, right? By the way, the 2D, the 1 radius away from the Earth above ground is humongous. For example, satellite orbits around the Earth for 42 times 164 kilometer. So that's way, way, way less than 1 radius of the, not way, way, way. That's less than the radius of the Earth. So satellite orbits around on the Earth, like around here. What does it mean? So satellite is around here. So you're going to have a still significant gravitational force exerted on a satellite up in space. So we're going to talk more about this in the next video.